The Structure of Existence by Dan Etchegoyen. This video is a series of impressions, ideas, and even some revelation on the nature of reality. These observations range from the trivial to the transcendent, but they all reflect on a greater whole. The relevance of each page depends on the viewer. This is mostly a picture book with words as needed. I guarantee new ideas for everyone, but no proofs, just perspectives. This is a book of scientific metaphysics, also called natural philosophy. Make of it what you will. If you want to know the secrets of the universe, think in terms of energy, frequency, and vibration. Nikola Tesla. Part 1. Einstein's full equation reduces down to the famous E=mc² for objects at rest. Further simple algebra shows the four elements, mass, energy, space, and time, as a proportional array, as simple as 1 is to 2, as 5 is to 10. The elements of existence shown on an even footing, each defined in terms of the others. All things exist as both mass and energy, as particle and wave. This dichotomy persists in the field of space and time, a dichotomy in a continuum. The three spatial dimensions are x, y, and z. Time dimension can be depicted as a rotation in an object, as a plane passing through an object. The fourth dimension can be seen as any motion or change in 3 dimensions. Instead of 4 dimensions, some of my models will use only 1 dimension of space and 1 of time. This is to simplify the complex and show the basics more clearly. The cost is completeness in full complexity, which cannot be shown. The 3 kinds of curvature, elliptical, parabolic, and hyperbolic, all exist in 1, 2, or 3 dimensions at least. Section any cone and you get elliptical, parabolic, or hyperbolic, depending upon the plane angle relative to the cone surface and its rotational axis. If you travel in a straight path, flat on a cone, any path direction that goes closer to the apex of the cone will change inclination and move away from the apex. Whether the returning line is parallel, diverging, or crossing the first part of the line, all depends on what percentage of the circle the cone laid flat would cover if laid flat. Curves similar to the ellipse, parabola, and hyperbola will occur. All mass-energy things are self-reflecting standing waves, which appear to flow in 2 contradictory directions at the same time, a bistable image. Standing waves all resonate with each other. Node points on a standing wave are at an equilibrium with no lateral motion. Exchanges are in space and time on the diagonal of both at once. All rational fractions resonate simpler ratios more strongly than complex ratios, but they all interact. Existence is the constant change of rational harmonic resonances, call it music, among all things, think tension, release, and resolution. Existence is participatory. Persistence means being attuned to resonate with the whole. Enter quantum mechanics. Entities that do not resonate do not persist. Standing wave entities contain both parts of the self-contradictory unity, objectivity and subjectivity. How they compete and cooperate is shown here in pictures as dichotomy and continuum. For the dichotomy, either or, you have parallel extremes in 1 dimension. For the continuum of both and neither, you have a diagonal and the extremes are on the perpendicular. Nothing can be described directly. The unity of all things can only be described as indescribable, a self-contradictory description, but even ordinary things cannot be described directly. What are described are the attributes of a thing. Attributes are of a divided being. A being divided can exist in any number of parts. Classes of attributes coincide with the number of divisions, duality, trinity, quaternity. The unity possesses no attributes to describe, but a divided being is characterized by the number of divisions being expressed. When the description set has 2 parts, there is duality. The unity can be divided into any number of parts. A unity divided into 3 parts is a trinity, which need not have a religious reference. When you divide the unity into 4 parts, one reality you get is mass, energy, space, and time. Each divided part of the whole is a whole thing itself that can be further divided again by any number, a fractal structure. All things can be compared to all other things with matching numbers of properties, making tables of abstract correspondence for each number. Duality is found everywhere, classically called the objective and the subjective. The universe has duality perpendicular to itself, like time and space. Everything has both objective and subjective extension into, and is on the diagonal of, space and time. Objectively, all things are different from all other things, a different time, different place, or both, in the concrete measure of all things or events, which are the same thing. Subjectively, all things or events are similar to all other things in the abstract process of being. For example, Saturn, with its rings and moons, is abstractly like the Sun, with its asteroids and planets. All things are endlessly similar to all other things, and unendlessly different from all other things as well. You cannot say that men are more similar to women than different from them, unless you specify an attribute to compare relative to other things. For example, a man is more like a 200-pound rock than an ant if you are comparing masses, but much more like the ant if you are comparing complexities of systems. There is virtually no end to the number of comparable attributes between things, in all the divisions of being, both objective and subjective. Everything is the same as everything else, and everything is different from everything else too. Both and neither, both and neither. Description of a thing can be more and more objective and concrete, or the description of a thing can be more and more subjective and abstract. Things themselves reflect, or resonate, to different degrees in the concrete and in the abstract, that is, in the objective and the subjective. Exchanges are of mass, energy, and information through time. The objective and the subjective, harmonic nodes, each exist according to its reflective resonant capacity and their effects on a thing. For example, spoken words as a form of communication can cause a huge range of responses in people, but not affect fragile objects at all. A thrown rock as a form of communication will have a more concrete effect on fragile objects, but the effect on people would likely be less complex or subtle. All interactions have objective and subjective components. Objective reality details the universe that can be measured. There must be a physical change. Subjective reality has changes that are only indirectly physical. An opinion on who is the villain and who is the hero can change with more information or perspective. There is no better subjective feedback change detector than deep mutual eye contact between two people, which can be a subjective challenge. Deepest levels are achievable when gazers' focus is truly only on the other participant and not on the self. When a deeper eye contact is achieved, both participants experience it together. This is a change that is strictly subjective, without motion. Objectivity and subjectivity are equally important in the structure of existence, but different. Objectively, all things or events are different from all other things, and all perspective viewpoints see the same pervasive, repeatable physical reality everywhere. Subjectively, all things and events are similar to all other things in some way. Every entity has a unique subjective reality. If someone looks in Schrodinger's box, to them the cat is now either alive or dead, but as I have not looked, to me both possibilities still exist. I live in a different subjective reality from anyone who has looked in that box, or for that matter had any experience at all that is not identical to my own. There is the self and the not self. Each makes exchanges in its own realm and into the realm of the other as well. Thus, this little chart. Gödel proved that any finite consistent set of axioms must be mathematically incomplete. It follows logically that a finite complete set of axioms would have to be inconsistent or self-contradictory. It appears that finiteness, consistency, and completeness may not exist together in this universe. Finiteness versus infinite, consistent versus infinite, complete versus incomplete. This is finite, consistent, and complete, which cannot exist. Instead, you have to have inconsistencies in the set. And these are what I see. The motion of a wave or particle through space and time relative to an observer occurs in three aspects relative to the direction of motion of extension: along, across, and around. Varying these three values alone can create almost any simple shape. Each of the three surfaces has opposing lines that pass through that surface and adjacent lines that define that surface. An extension of dimension can be straight or curved. A straight line has ends that meet at opposite infinities. This is a global line. A curved line has ends that meet locally to form a circle. This is a local line. The smaller the circle, the more local the line. Waves, or particles, enter new time and space to persist and resonate with the whole. Extensions into space and time are both curved and straight. Resonances are reinforced and cause persistence. Curved lines and straight lines can both have waves on them. Node points may project or reflect waves, like a window that is half silvered. At specific wavelengths or frequencies, resonance reinforces regular divisions of the whole. There are quantitative relationships between various spatial divisions of the whole. One circular nesting of triangles equates to two circular nestings of squares. The small circles are half the radius of the large circles. In any pie-cut circle, a reflection inside one wedge recreates a projected path through the circle. A 90-degree corner directly reflects projections inside a grid to its rational square tessellations can be duplicated by a reflection inside a single square. A cone rolls out as a wedge. When a path on the surface of a cone completes a circle around that cone, the line that would project into the next wedge is instead overlaid onto the same wedge at a new orientation. Eventually, the line will no longer cross the fall line and be oriented to not cross any other wedges. The propagation of resonant being travels through space and time on a path that is both straight and curved. There are two paths from A to B on a circle. The two basic units of extension are diameter and circumference. The two paths from A to B are at 90 degrees to each other, and their lengths differ by pi over 2 to 1. How one path is measured will affect how the other path is perceived. These two paths are really extremes of a single wave complex that is both straight and curved. The extremes of 0 and infinite can be indistinguishable from each other. Resonances occur between the extremes. Simpler divisions of the whole resonate with each other more strongly than complex fractions do, but all fractions resonate. The line reflecting back and forth between A and B, opposing points on a circle, can also reflect around inside larger circles. At specific ratios, the straight unit of measure reflects around inside its larger circle at exact numbers of times, and that wave path is reinforced. All regular polygons are represented as the curved line can be of any size. All the points on the curved path from A to B have A and B at 90 degrees to each other from those perspectives. Two reflectors at 90 degrees to each other reflect as one, directly back, reversing the reflection. All the points On the straight path, see A and B, instead of 90 degrees to each other, at 180 degrees to each other. Any line reflecting inside of a circle, if it does not cross the center, it will reflect around inside that circle and can create repeating patterns depending upon the outer circle size relative to the inner circle size. Extensions into space, both straight and curved, can occur in consecutive 1-2 sequence. From each extension to the next, there can be reflection or projection. Units of extension into space are both straight and curved. A consecutive sequence of 2 or more extensions are, in a sense, identical to a single extension. The same properties that describe the whole, the parts, are themselves wholes with their own parts. The number of divisions resonating in the whole shows the kind of divisions resonating in the whole. Unity is described as indescribable, a finite, complete, but inconsistent description of the unity. Duality divisions are obvious everywhere and are classically called the objective and the subjective. Trinity divisions show the actions connecting both parts of duality, of course. There are 2 trinities, or triangles, one objective and one subjective. The 2 triangles become a single tetrahedron of information, as per holographic principles of black holes and universes. One aspect of these dynamic triangles is best expressed by M.C. Escher visually. In a flow around the triangle, the opposing bistable resonances are uphill in one direction and downhill in the other direction. Downhill is entropy, loss of potential and disorganization. Uphill is syntropy, the gain of potential and organization. The objective and the subjective flow through each other, entropy and syntropy together, resonating through each other. Mass, energy, and information all can be objective in duality or subjective in a duality, depending upon positioning, like rock, paper, and scissors. How 2 triangles become a tetrahedron is shown by Reverend Buckminster Fuller. For him, a triangle exists in 3 dimensions with overlapping vertices. 2 triangles fit perpendicular to each other, each between the overlaps in the other, to make a tetrahedron. This is the holistic minimum of information, one objective unit and one subjective unit together. Node points are standing wave points of reflection and projection. Node points have no lateral motion. All points in space are potential node points, where waves may resonate, reflect, or project. Change between nodes is lateral. Change at the nodes is angular. If you stand between 2 opposing mirrors, you see an infinite tunnel of rooms containing reflections of yourself. If you stretched a standing wave rope between those 2 mirrors, it could be difficult to see where the real rope ends and the waving rope reflection begins. Projection and reflection can both appear to be in the same space. There are 3 fixed standing wave node points on a triangle. The standing wave triangle lines project beyond the 3 nodes of reflection. Changing the number of waves between nodes without also properly changing the wavelength will change the shape of the triangle. Information on a standing wave feeds in the either direction, so there are 2 3-part standing waves on a triangle, one in each direction, a bistable resonance. If you need to imagine waves crossing in a common node point at 90 degrees, you can change the curvature of the surface accordingly. All things are unendingly different, objectively and concretely. All things are unendingly similar, subjectively and abstractly. All things resonate with all other things. The number of divisions of the whole that the whole is divided into tells the kind of divisions. Any divided part is also a whole on its own and can be divided again by any number. The unity is described as indescribable. Duality is obvious everywhere. And there are 2 trinities, objective and subjective. They are the 2 triangles of action interfaced into one tetrahedron. The objective 3 actions are be, do, and have. They represent the three kinds of verbs, the parts of speech for action, the being verbs, the action verbs, and the having verbs. The subjective three actions are feel, know, and interact, or resonate. Without endorsing Christianity or any other religion influenced by Judaism, I should point out another set of parallels reinforcing the subjective trinity. Reference to the heavens and the earth correspond to the subjective and the objective realities, and the residents of heaven, Father, Son, and Holy Spirit, correspond to the subjective trinity. God the Father links to the feelings of love, God the Son links to the knowing of the world as a living being, and God the Holy Spirit links to the interaction between God and man. All things exist according to the same set of abstract rules. Objective and subjective reality together reflect on the past and project on the future. Things resonate as they will, with the goal being persistence, continued being, both physically and non-physically. Even consciousness follows the same set of rules. New work by neuroscientist James Kozlowski at IBM shows that the loop of consciousness includes limbic impressions, which are feelings, behavioral realizations, which are knowledge, and sensory engagements, which is interaction, the three subjective actions of existence in consciousness. The three objective actions of existence resonate indirectly with the three subjective actions of existence. The two triangles would either be represented on a single tetrahedron operating together against a unified dynamics of an opposing tetrahedron, or the objective and the subjective triangles can be represented on opposing tetrahedrons with changes of either resonant state also changing the orientation between the tetrahedrons. Dual tetrahedrons form a four-dimensional crystal whose 6 pairs of crossing edge lines always touch, no matter the orientation between them. This is a set of dual tetrahedrons. They have a square frame like this, and they can go back and forth this way, and all the edges always touch. All pairs will always touch. From a triangular perspective, you can rotate it. You do them both at the same time. One is going left-handed with its circles, and the other is going right-handed with its circles. You can switch to this, or you can even go to a single unit. All these are possible with all the edges continuing to touch at all times. Supersymmetry. Orientation changes occur when the standing waves on the edge lines change frequency. When the standing waves change, the node points change locations. The two tetrahedrons' edge lines cross at mutual node points on the lines. When a standing wave changes harmonics, the node moves and indirectly influences two tetrahedrons' mutual orientations to create a new common point for still nodes on a crossing lines to coexist. Node changes and orientation changes are harmonic, music-like progressions that resonate in 12 related dimensions and have a direction of motion and handedness. The resonant polygon inside the circle also resonate outside the circle in bigger circles. The 12 strings that vibrate in the four-dimensional crystal, that is a dual tetrahedra, also resonate outside the enclosed geodesic. There is space inside and outside the geodesic for resonances to occur. A tetrahedron and its dual form all 12 diagonals on the face of a cube. A tetrahedron has two different two-dimensional symmetries depending on perspective. Both the 1-3-1-3 and the 2-2-2-2 patterns of perspective on the tetrahedron are tessellation patterns for 2 dimensions. An extension into space is both curved and straight. As a one-dimensional line, a two-dimensional extension is made by having duplicate linear extensions located laterally to the first extension in the same direction, whether set perpendicular to the original extension or staggered on the diagonal. These two arrangements of a two-dimensional extension of space are the basic tessellations of a plane, and they offer different resonances and wave flows. Squared and staggered tessellations create two different wave patterns. Square tessellations leave two perpendicular directions for waves to travel. Staggered tessellation yields three directions that waves can travel on in two-dimensional space. In three-dimensional space, the closest packing of spheres shows both of these two-dimensional patterns from different perspectives. Four spheres make a tetrahedron with its square and triangular perspectives. There is no center sphere in this tetrahedron, but if you do the same, closest packing of spheres around a tetrahedron, around a sphere, you get the vector matrix, also known as the cube octahedron. Extending into three dimensions, circles turn to spheres, layer over one two-dimensional extension of space with another two-dimensional extension. Both tessellations stack differently and only with like kind. From square tessellations, stacking vertically will make a cube, and stacking offset is in between units will make a pyramid, which has four sides, slanted staggered tessellation. From the triangular tessellation, vertical stacking makes a prism. Offset stacking makes a tetrahedron, which has three perspectives of the square perpendiculars. Both the pyramid and the tetrahedron are symmetries or perspectives of the closest packing of spheres in three dimensions. Other stackings also exist between the maximal and the minimal. Triangular tessellation is very different from square tessellation. On the squarely tessellated field, for every unit of extension, there is one gap surrounded by four units, simple stacking. On the triangularly tessellated field, there are two gaps per unit, each one surrounded by three units. Stacking the triangularly tessellated field has stacking options unavailable in the square field. In the square field, the third layer of gap stacking will again line with the first. In triangular field, the third layer of units may or may not align with the first, as there is a choice to either recover the previous gap or cover the gap that had previously not been covered. Units stacked and their gaps are different for square and triangular tessellations. For squares, they're the same, but they're different for triangles. Another difference between the square and the triangular tessellation of the plane: compass magnets placed in the pattern of the two tessellations will influence each other in very different patterns. In the square pattern, all the magnets will wind up pointing in the same way, one of four directions available in the two-dimensional array. Think lowest energy level. In the triangular pattern, all the magnets will align along one of three directions of resonance, but alternating lines will point in opposite directions. The area covered by either such uniformed field pattern will be called a domain. Magnetic influences in the various three-dimensional stackings are likely at least as interesting. This is just some images I've made trying to show the relationship between the triangle and the hexagon in the tiling of the plane, to try and understand their relationship. The basic thing to know is that when you actually do the hexagons, you have removed spheres or circles that allow for straight lines in any direction, so it's always indirect or another level up of direct only, as there are no direct lines in three dimensions if you're using the hexagonal. A few visual perspectives relating to topology and geometry. A resting spot. This is the standard model of elementary particles, and this presentation does a poor job of showing the symmetries and relationships to the forces of nature as they precipitate out the different fields in our universe during expansive cooling. It does not show the clear relationship between fermions and bosons for each field, for each force field, and I believe my organization does better. This graph sorts out the forces along with the associated boson and fermion for each force. The field order is made as each force separates out through cooling, expansion, and spontaneous symmetry breaking. higher energies in heavier quarks, muons and taus, and the neutrinos means shorter wavelengths. And since two tetrahedron as duals orient to each other via their mutual nodes, shorter wavelengths allows for smaller changes to occur between the tetrahedron in their orientations, and catalyze that full change back to a new low energy state of orientation, a progression of resonant states. Call it music. The combined color force is reflected inside the baryon and also projected outside the baryon as the strong force between baryons. The cooling of the universe breaks out each force from the remaining symmetry. Without energy exchange, the electromagnetic force cools to two static forces, the electric force and the magnetic force. The topological distinction between them, sphere versus toroid, is notable. In this array of the forces, the two really not mutually, start again, in this array of forces, two of those forces are really not mutually interactive with the others. The Higgs force is the same everywhere, and the weak force does not conserve basic symmetries like spin parity and parity, like all the other forces do. The weak force is temporary, coming into existence only during decay or transition of protons and neutrons, and the changes of any group nucleus of protons and neutrons. When the change is done, the weak force ceases influence. This leaves gravity, color, electric and magnetic forces to compare abstractly with the elements of reality, mass, energy, space, and time. Quaternity, shown by the dividing of unity into four, the display can be a table or it can be a geodesic. A tetrahedron is described by Escher and Fuller. The tetrahedron has four vertices and four opposing facets, along with six edge lines connecting the 4 points. The tetrahedron is the only three-dimensional geodesic that is its own dual. The duals, with their two tetrahedrons, have 6 pairs of crossing lines and 4 pairs of opposing facets and vertices. The objective and the subjective interact, exchanging energies, information, and mass. These are some examples of the 4 divisions of a thing and how geometric displays show clear relationships not obvious on a flat table of correspondence. Divisions of the unity greater than 4 exist as well. Dividing by 5 yields no obvious tables of correspondence, but there are many mathematical connections between the number 5 and the constant phi. Phi is found in the distance relationship between crossing points on a pentagram, and the square root of 5 is found in the square Cartesian generation of phi. The square Cartesian, the phi is deeply fundamental number with many ways of being expressed. This number, or its inverse, which is the same number minus 1, is found, or at least approached, by the Fibonacci sequence, where every number is generated by adding the previous 2 numbers in that sequence, starting with the number 1. The relationship between any 2 numbers in the sequence approximates phi. The larger the numbers, the more closely so. Divided the unity by 6 yields hexagons in the flat space and cubes in 3 space. That could be 3 axes of space, x, y, and z, and 3 axes of time, past, present, and future, shown by the distances along each axis. Different distances along each axis will have different resonance qualities, depending on the firmness of past reflections and the resolution of future projections. Dividing the unity by 7 displays a circular nature actually found in all the divisions of the unity. This circularity can be seen in harmonic structures of Western music. This standard scale can be seen to have 7 different notes that comprise it, or 8 notes if you include the circular return to the starting note, but twice or half the frequency. All things resonate at all scales. Another challenge to the status quo on how things are arranged is this depiction of the periodic table as a fractal by Melinda Green. There is some order to the primes. How they are arranged within the real numbers shows the patterns differently depending upon how the numbers are arranged with squares, either as a square, triangular, square, or circular, spiral. To write down numbers, we use placeholding, ones, tens, hundreds, etc. We use base 10 and with numbers 0 through 9. In base 10, one order of magnitude is 10 times as much, or one hierarchical level greater, base 10. Numbers can be written down in any base, and base 2 is binary with only 0 and 1. By writing down the counting numbers in binary and then coloring in the zeros blue and the ones orange, you can see a pattern of mixing in the range of hierarchies and placeholding. Think levels of duality. In base 3, a self-similar pattern is even more evident from one level to the next. Right here. The abstract structure of existence can be seen as a regular fractal with 8 parts as 1. Whether you've got all 8 or 3 or 1, it is all the same. Doing and knowing are each the action middle of the two dynamic triangles. They are at 90 degrees to each other where they meet. Halfway is square to both. Whether the plane between objective and subjective is centered or not, the perimeter remains constant as long as the dividing plane is perpendicular to both doing and knowing. Some abstract parallels in the regular fractal 8 array. Resting spot. A spinning object experiences no acceleration from gravity. Experiencing no acceleration is stable if spinning on its own major or minor axis, but spin around the semi-major axis is unstable and will decay into spin around the major or the minor axis. A spinning object that is experiencing acceleration from gravity will resist that force by moving its center of gravity away from the direction of force it is experiencing. Whether it's rotating around this way or along this way, it always gets as high as it can, resisting the force of gravity. The more spin, the greater the resistance and counterforce. Gyroscopic precession shows the indirect influence of angular acceleration on linear acceleration. Local angular inertia resists global linear inertia. We know the curved path from A to B has every point on it at a mutual 90 degrees to A and B together. Now, if we reorient the frame of reference, we can see that this relationship is recast as x and y, with the circle diameter as the hypotenuse. Pythagoras' observations on right triangles and area is broader than often understood. Not just squares, but any similar shapes attached similarly to a 90-degree triangle will have similarly summed areas. Even the icon of squaredness, the square numbers, are found in the triangulation of space, in the gaps. If you invoke Pythagoras using half circles, an interesting feature of the relationship appears. The tangent for either side with the hypotenuse yields the length of the other side. In fact, there is a general inverse relationship between the sides. It is clearly stated by the equation, but by extending the symmetries to a full circle, the tangent relationship is visually made clear. Using a full circle, we see the two sides are at 90 degrees to each other, are symmetrical. The diagonal length remains constant while the two sides show their inverse relations. There are different images for this relationship depending upon what you hold still and what becomes functional motion. The range of rectangles in a circle shows a common diameter or hypotenuse. The same range of rectangles bound by a diamond border shows a common perimeter. This constant perimeter is found by passing a plane through the tetrahedron from the square perspective. Passing a plane through the tetrahedron from the triangular perspective shows a constant ratio between the area of the base, or any side, and the volume of the tetrahedron. There is no center to a circle. There are smaller concentric circles in all circles as small as you want, down to a Planck-sized harmonics of squared or staggered circle units of extension. Instead of a diameter, there is a tangent between the inner and the outer concentric circles. If the relative sizes of the circles keeps the tangent the same length, then the area between the circles remains constant. This is Mamicon's theorem. When the inner circle is virtually zero, the tangent is the virtual diameter. As the circle pair gets bigger, for the area between them to both circles to remain constant, the circles become closer and closer together to keep the same length tangent. The tangent line that defines the area between concentric circles can reflect around, making tangents in every direction. Harmonic divisions resonate. 2 can resonate with 3, and 3 can resonate with 4. All resonant circle pairs resonate with all others. They all share a common length and a common area to resonate in. From the largest to the smallest, all is one. The straight line tangent, reflecting back and forth like a diameter inside a circle, can go around the smallest inner circle on both sides as it goes back and forth, because the straight line is actually a local segment of a globally curved line whose center is infinitely far away. That impossibly slight curve in the line bends nicely around that impossibly small center circle. Each new tangent of concentric circles defines the same area between the circles, but creates an arc dividing the circle into one more part than before. This picture of consecutive perpendiculars has each new hypotenuse and radial adding a smaller division to the circle, and this image appears as an approach to the e to the I pi plus 1 equals 0 equation explanation. I'm not really sure if it's relevant, but I've seen it, so I shared it. Other ways of holding one part still and looking at another. Whether you've got parallel lines or a single point that holds still, whether you're using 2 points or 1 point. Different ways of describing it. This page is pure speculation based on unsure assumptions. A neutrino conundrum is that it has rest mass and yet travels at virtually the speed of light. Nuclear interactions release both neutrinos and photons together. If the release of both particles, neutrino and photon, together are linked so as to have a fixed area between them, or magnifying up to a volume or hypervolume or whatever, then if they are fixed, have a fixed area, so-called, between them as they propagate away from their source, then as the two linked circles expand, they keep getting closer together. The inner circle is traveling faster than the outer circle, even if just vanishingly so. So the leading neutrino is slower than the following faster photon, but the two would never meet. A curved line is local, and a straight line is global. As the observer becomes more local to a curved line, the more global the line will appear to that observer. Where local lines are concentric, global lines are parallel. Circles cross at 2 local points, and straight lines cross at a single point locally. All lines of discourse on the nature of a thing are at a tangent to unity's self-contradictory or indirect expression and will miss the mark. In archery, to miss the mark, the bullseye, was to sin. The first circle is sin 1, the second is sin 2. To sin is to be imperfect, to fall short of being perfectly square with the target directly. We exist on the diagonal. Direct reflection, a perfectly squared gaze of the unity, is impossible. Even the finest attempt at truth will only be a tangent to reality. And this great truth of the certainty of any description of reality to miss the point itself completely misses the point. The center of a circle is not a point, but a smallest circle, a single extension, straight and curved, of space. Even the smallest finite circle avoids some mathematical challenges found in point-like infinities. Conflicting statements in lower dimensions can both be true in higher dimensions. In Edwin Abbott's Flatland, there is only x and y. If a flatlander were enlightened on the z-axis, any attempt to describe it could only be in terms of x and y. The z-axis would be described as being perpendicular to both x and y, but since in flatland there is only x and y and they are mutually perpendicular, then such a local description would be self-contradictory, and only from a higher perspective or dimension could the conflict be resolved. Different forces fall off at different powers per distance. If you imagine that, in a sense, all there is the universe experiencing itself, then the size of the reflection of the self is an indicator of the field strength and is modified by changing both the number of dimensions the reflection is in and the curvature of the reflecting surfaces. Even confined quarks show field strength magnification reflected within the sphere or ellipse type curve. If you roll a half-size circle around a full-size circle, the ellipsoid is a straight line, and the hypocycloid is a nephroid. Rolling smaller relative circles around the full-size circle will yield numerous examples of both, until finally, at local scales, they are merely cycloids of a straight line. If the diameters of both circles are rational fractions, then so are the circumferences. A unit distance, whether a radius or a hypotenuse, is both straight and curved. The unit circle crossing the xy axis creates both x and y as a trigonometric and as a trammel. The equations for both are identical, but a trammel rotates in the opposite direction. The common space for both is a circle, depicted in yellow. Trammels are diameters of the inner circle as it rolls around inside the outer circle. Any diameter of the inner rolling circle has endpoints that move in paths that are perpendicular to each other. A radius path looks the same no matter the length, but a trammel path looks very different depending upon the distance from the center. The center of the depicted circle set's trammel is the yellow circle shown, not a point but a circle minimum. Extension of position away from the center can be in either the blue direction or the red direction of the inner circle. Paths less than a full small circle away from the yellow circle are then orange or green, depending. Paths inside the circle, going from yellow to red or blue, become less round and then are lines at the diameter, and then become rounder again as the trammel paths extend beyond the smaller circle towards infinity. Red moves towards burgundy, and blue moves towards purple, and the colors become one at infinity as perfect circles that yet overlap each other. When two wave patterns overlap, they interfere, creating a meta pattern of both patterns together, yet neither alone. This higher pattern recounts attributes of both contributing patterns. If the two patterns are the same, the higher pattern can look the same as the contributors, but on a magnified scale. If the true interfering patterns lie in the same plane, then the resulting interference pattern is fixed in space relative to its constituents. But if, however, the interfering patterns that exist in two dimensions are themselves separated in the third dimension with a gap between them, then the meta pattern may be still relative to the observer, even if the observer moves past the contributing patterns. This can be seen on walkways over freeways with fences on both sides. The interference pattern of the two fences actually is still relative to the view of the cars passing it, but is seen to move through the fences as observers move past the overpass walkway and its fences. The scale difference between the two patterns in overlap and their higher, larger meta pattern can be altered by three kinds of spatial changes, all relative to the fixed observer. First, you can change the size of one contributor or relative to the other. Second, you can change the third dimension distance between the two contributors. Or third, you can change the angle between the two contributors. These three types of extension into space, along, across, and around, are again apparent. Patterns interfere to make higher patterns. Those higher patterns interfere with each other, even higher patterns, making up the world in the finest detail in the grandest scale. At the bottom of this majestic creation are the original waveforms before they interfere with each other. Before waves interfere with other waves, they exist and propagate in one of three shapes. These waveforms hold their shapes as they propagate and have no scale limits. All three forms exist in 2 dimensions and 3 dimensions at least. The first waveform is the circle in 2 dimensions, or the sphere in 3 dimensions. The 2-dimensional wave is easily made by creating a wave fluctuation on the surface of a pond or pool. Just toss in a rock. In 3 dimensions, the spherical expanding wave is seen by the shock wave of a bomb blast. The second pure waveform is the V-wake of a wave whose source is traveling faster than the wave that it is making. In 2 dimensions, the V-wake happens with any speedboat, and in 3 dimensions, the wake is a sonic boom from an aircraft flying faster than the sound that it makes. The third wave that holds a shape as it propagates is that of a torus, commonly seen as a smoke ring. The 2-dimensional version of this wave would be the twin vortices in the water caused by an oar stroke. While the spherical and the conic waveforms can be continuous, the torus propagates in discrete units. While the spherical and conical waves will expand to reach all observers, a torus propagation is point-to-point and is an exchange waveform. The torus is the dynamic form of exchange and occurs on all scales from hurricanes to neural impulses, photons to tornadoes. Our universe is described as a local density fluctuation, in other words, a wave pulse, a place of constant change, which is an oxymoron. Mass and energy change in relationship to each other in and with the field of space-time. The wave shapes of the sphere, the cone, and the torus each maintain a different unfoldment of wave space, yet each is clearly a dynamic, changing surface, a wave pulse that has its own space-time field of masses and energies. Consider the dynamic torus propagating along as a 2-dimensional universe, 1 dimension of space and 1 dimension of time. Our universe is not so simple, nor necessarily a torus, but Einstein's equations are topological and dynamic, and the simple torus model allows for process visualizations in a 2-dimensional version of the full reality. Motion on the surface of the universe is different in the time axis than in the space axis. While in the space axis, motion can be in either of 2 opposing directions, in the time axis, motion of the torus is in one direction only, the direction of propagation. Actually, the standing waves on the torus are all standing laterally still as time moves past them as a unit. The rubber sheet model of gravity shows space to be distorted by mass. This distortion is due to acceleration of mass and energy perpendicular to the plane, in this case by gravity. Einstein says gravity is indistinguishable from acceleration. Just as there is a straight path and a curved path from A to B, there is linear and angular acceleration and motion. While a propagating torus moves in a straight line, all the points on the surface move in circles and experience angular acceleration. The tension field that separates the inside of the torus from the outside experiences angular acceleration and can be deformed by the masses and energies of the propagating torus, just like the rubber sheet experiencing gravity. If you blow a big, slow smoke ring softly into a room with very still air, as it propagates and slows even more, the smoke ring will eventually possess a bulge of mass and energy moving around with the smoke ring. The bulge is a gravitational depression that will attract other masses and energies. Eventually, the bulge gathers enough mass and energy to collapse the field and emit a new, smaller torus with the time and space axes switching places. Inside this black hole, motion change through space is impossible, fixed at the moving circle of the singularity, but motion forward or backward in time is allowed. The dark energy responsible for increasing expansion will also contract the universe eventually. It is the energy of propagation. Expansion is linked to propagation. Gravity is linked to inertia. Local inertia collapses space and time. Global inertia drives space and time. There are some clear relationships between the areas and volumes of geometries and geodesics. Some notable surface areas. The cone, sphere, and cylinder have a deep volumetric relationship. With equal height and radii, the cone has 1/2 the volume of the sphere and 1/3 the volume of the sphere. So the sphere has twice the volume of the cone and 1/3 the volume of the cylinder. If you solve the equation in simplified terms, the final relationship is revealed: H equals 2R. To be expected when the solids all fit in a 1 by 1 by 1 box. As an aside from the information on the last 2 pages, it seems that the sphere is not alone in having the least area per volume. The volumetric relationship is quite general. As long as the radius for the cone base and the circle circumference and the cylinder circumference are all the same, the cones and the spheroids can be of any height at all as long as the total heights are the same. The volumes will all be the same, relatively. For images invoking volumetric equivalency, a given height of cones can be displayed in different ways and yet be identical. There need be no issue using whichever image best suits the picture. Same thing goes for spheres, but that imagery is needed less often. The sphere and the cone both are iconic as dynamic waves and as static volumes. As odd forms out, the torus and the cylinder have their own relationship. The torus is to the cylinder as the cylinder is to cubic space. The volume per length of the straight globally curved cylinder is the same as the round locally curved torus, if measured along the center line for each. Volume increases on the outside of the curved center line are offset by volume decreases inside of the curved center line. The spheroid, the cone, the toroid, and the cylinder are all deeply connected. The following is an analysis of those relationships in the nature of reality. Any inversion of the conic is acceptable. The toroid is often seen as 2 exchange particles propagating in opposite directions. 2 fit properly inside the unit cylinder. The sphere and the cone are the same, except for the source of the wave moving faster than the wave being created with the cone. Both can be continuous. Both waves pass across all observers. If the source travels at the speed of the wave, all circles will touch at either 1 or 2 points that are tangent to all. All 4 shapes share an axis of rotation. The sphere and the torus are the same, except for the offset of the torus circle from the center line of the sphere's circular rotation. The amount of the offset from circle determines whether the torus is a loop, a horn, or a spindle. A torus is a discontinuous waveform and moves from point to point. An inside-out torus has its time and space axes reversed. The tangent length between concentric circles determines the area between them, no matter the 2 circles' size. If you move that x and y circle pair through the z-axis, you create the volume of a cylinder, even if it's in the shape of a tube. The plane tangent to the inner cylinder intersects the outer cylinder to form a perfect square at any radii set. The height is fixed, as is the circle tangent. The sphere has a similar feature. A vertical plane is tangent to the axis of rotation and sections pole to pole across the equator. If the axis is a cylinder, then the height, diameter of the tangent circle and the volume outside of the inner cylinder remains constant with the height. 2/3 of the cylinder or tube is the same height. Let me try again. The sphere has a similar feature. A vertical plane is tangent to the axis of rotation and sections pole to pole across the equator. If the axis is a cylinder, then the height, slant, diameter of the tangent circle and volume outside the inner circle tangent remains constant with the height. 2/3 of the cylinder or tube of the same height. Clearly, setting the inner circle cylinder to 0 will simplify things for many calculations. Each concentric area defined by a constant tangent is the same. If you spin a concentric area around a vertical axis, then the volume swept by that area, bound by outside the tangent, will always be the same. The cone is the same as the cylinder, except that the conic is twisted 180 degrees out of phase, top to bottom, the maximum. Lesser phase twist change yields a hyperbolic curve and straight lines on the diagonal from top to bottom. The angle of the hyperbola gets sharper with increases in twist, but remains a hyperbola. Going from the flat-sided cylinder to the angled side of a cone pair is going from local to global. The conic also has a given height and base diameter. Twist separates inner and outer circles as defined by its straight diagonals. Full twist brings inner cylinder to 0 radius. I'm not certain that the volume between the inner cylinder and the outer twisting cylinder remain constant with the tangent between them, but it seems reasonable. The volumetric shapes of the sphere, cone, and cylinder are swept by two-dimensional shapes around the axis of rotation. These shapes are the diamond, the circle, and the square. Coincidentally, these shapes have meaning in LP space of math. LP1 is the diamond and has a pi equal to 4. LP2 is the circle, and pi is pi equal to the normal 3.14. LP's infinity is the square, and pi again is equal to 4. In LP math, pi is always between 3 and 4, inclusive. The cone, the sphere, and the cylinder are all swept around the vertical axis at a tangent, but the torus, being offset, becomes perpendicular to the edge of the central cylinder. The four solids have many common similarities. Removing them leaves most abstract objects to compare. The four abstract shapes displayed across X and Y together can be spun on either axis to the same effect in generating relative volumes. They all still contain a mirror symmetry on the diagonal. Different divisions of the cylinder silhouettes into areas and volumes show interesting relationships of quantities. Another view, this time of the silhouettes and spun volumes of the different abstract parts, each relative to each other. All four objects can be divided into pairs in three different ways. This is about as full of an abstraction as I can manage. I'm hoping this chart will have some points of interest for the right groups. It's not perfect yet. If this book has had even a fraction of the effect on you that I believe is possible, please share, like, and tell a friend. If you really liked it, send your comments, questions, and possibly a thank you with a token gratuity for my life's work to structureofexistence@gmail.com. Thanks for watching. Have a good day.